Imagine a world shrouded in mist, where the air hangs heavy with moisture. This is a swamp planet, defined by its abundance of water and lush, humid environments. These planets exist in the habitable zones of stars, with surfaces covered in vast swamps, marshes, and wetlands, creating a world teeming with life. The combination of abundant water and a humid atmosphere creates an environment perfectly suited for life to thrive, albeit life very different from what we know on Earth. The swamp planets, with their unique conditions, could give rise to a breathtaking array of life forms. Imagine ecosystems more diverse and vibrant than any found on Earth, with life adapted to the challenges and opportunities of a waterlogged world. At the microscopic level, swamp planets could be teeming with bacteria and other microorganisms, playing a crucial role in the planet's ecosystem. Plant life on a swamp planet would be equally diverse and unusual, with towering trees and dense, humid understories. These trees could have adapted to thrive in waterlogged soil, developing unique ways to access nutrients and oxygen. Animal life on a swamp planet would be just as extraordinary, with amphibious creatures perfectly adapted to both water and land. Insects could flourish in the humid air, their buzzing a constant reminder of the planet's vibrant ecosystem. The waterways of a swamp planet could support a rich diversity of aquatic life, with fish adapted to navigate murky waters and low-oxygen environments. Some creatures might evolve bioluminescence to communicate or attract prey in the dimly lit depths. The air on a swamp planet would be strikingly different from our own, a mixture of gases that would be both alien and strangely familiar. One of the most significant differences would be the higher concentration of water vapor, creating a perpetually humid environment. This dense, moisture-laden air would trap heat, contributing to the planet's warm and stable climate. The composition of other gases in the atmosphere would depend on various factors, including the planet's volcanic activity and the types of life present. Methane, a potent greenhouse gas, could be abundant, released by the decay of organic matter in the swamps. Carbon dioxide, another important greenhouse gas, would also be present, although its concentration might be lower than on Earth. Plants on a swamp planet would absorb carbon dioxide for photosynthesis, potentially offsetting the amount released through natural processes. Nitrogen and oxygen could also be present in varying amounts, with oxygen potentially being less abundant due to the decomposition of organic matter. The image of a swamp planet often conjures up visions of a world draped in shades of green and brown, but the reality could be far more diverse. The type of plant life would be a significant factor influencing a swamp planet's color. Plants on a planet with a red dwarf star might have evolved to utilize a broader spectrum of light for photosynthesis, resulting in foliage with hues of purple, orange, or even black. The composition of the water and soil could also contribute to the planet's overall appearance, with high concentrations of minerals or dissolved organic matter tinting the water. Atmospheric conditions could further enhance the visual diversity of swamp planets, with a thick, hazy atmosphere casting a perpetual twilight over the land. Imagine a swamp planet orbiting a red dwarf star, with dim light bathing the landscape in a perpetual twilight, illuminating bioluminescent fungi along the waterways. The water, rich in dissolved minerals, shimmers with an eerie orange glow, reflecting the faint light from above. Swamp planets, with their alien beauty and potential for harboring life, have long captivated our imaginations, serving as intriguing settings in science fiction literature, movies, and video games. One of the earliest and most iconic depictions of a swamp planet in science fiction is the planet Dagobah from the Star Wars franchise. Home to the Jedi Master Yoda, Dagobah is a world of mist-shrouded swamps, teeming with strange creatures and imbued with a mystical aura. The movie Avatar also features a swamp-like environment on the moon Pandora, with bioluminescent flora and fauna highlighting the potential for beauty and biodiversity in these alien wetlands. Video games have also explored the concept of swamp planets, often as settings for adventure and exploration, such as the Metroid series. The portrayal of swamp planets in science fiction, while often fantastical, serves an important purpose, allowing us to explore the unknown and imagine the possibilities of life beyond our own planet. As we peer deeper into the cosmos, discovering a plethora of exoplanets, the possibility of encountering a real-life swamp planet becomes increasingly tantalizing. Future telescopes and missions promise to revolutionize our understanding of exoplanets, including those with swamp-like characteristics. Advanced telescopes will allow us to study the atmospheres of exoplanets in unprecedented detail, identifying the presence of specific gases and providing clues about surface conditions and potential for hosting life. Future missions will focus on characterizing exoplanets and searching for biosignatures, utilizing technologies like high-resolution spectroscopy and coronagraphy. The discovery of a swamp planet would be a momentous occasion, capturing the world's imagination and fundamentally altering our understanding of life in the universe. The search for swamp planets and other habitable worlds is ultimately a search for ourselves, a quest to understand our place in the cosmos and determine whether we are alone in the universe.